Pythagorean Theorem, Unit 6, Lesson 2, worksheet. Let's start problem 1. Problem 1 says the vertices of three squares are joined to form a right triangle. What is the area of the largest square? We know that the area of square A plus the area of square B should equal the area of square C. So to find the area of square C, we add the two areas for square A and B. 25 plus 18 gives us 43. So the correct answer is 43 centimeters squared. Remember, the unit in area is always represented by the squared symbol, the 2 exponent. So the correct answer is D. Number 2. The screen on a computer monitor has a length of 15 inches and a width of 12 inches. What is the length of the diagonal to the nearest tenth of an inch? So we first want to write the Pythagorean theorem. We then want to draw a picture. So our picture is going to look like a standard computer monitor. Whenever there's not a picture drawn, please get in the habit of drawing one. Let's plug in pertinent information. 15 inches in length of 15 inches. So it doesn't matter where that goes. I'll plug in 15 here. And a width of 12 inches. We'll say this is 12 inches. What is the length of the diagonal? So I'm going to put a dotted line. And I'm going to put in my right angle. So anytime you're being asked for the diagonal of a rectangle or square, in this case a rectangle, you're being asked to solve for the hypotenuse. And we know the saying that we remember to associate the letter C with hypotenuse is, I see a hippopotamus. I see the hypotenuse. So now let's plug in our measurements into the Pythagorean theorem. We'll call this A and this B. It doesn't matter how you letter 15 and 12. You can reverse the letters and still get the same answer. So we have 15 squared plus 12 squared equals C squared. Let's square our numbers. 15 squared is 225. 12 squared is 144. And all that should equal C squared. Next step. Let's add 225 to 144. So we have 225 plus 144 to give us 369. Now, we know we want to take the square root of 369 to get our answer, to solve for C. Well, let's look at our answer choices. I want to use our answer choices to determine which number, when I multiply by itself, will get me 369. So obviously 9 times 9 is 81, so that's not even close to the number that we're looking for, 369, so I can eliminate that. I'm going to eliminate these decimals too, because I don't want to multiply 19.2 times 19.2 or 16.4 times 16.4. So let's look at 27. 27 times 27. Let's multiply that to see if we get 369. 7 times 7 is 49. 7 times 2 is 14, plus 4 is 18. And before you multiply by 2, add a placeholder, 0. 2 times 7 is 14. And 2 times 2 is 4, plus the one that we carried is 5. And we get 9, 12, 6, what's wrong here? So I think I made a multiplication error somewhere. Let me check my work. I'll come back to this in just a second. Continuing with problem 2, if you reread the problem, it says, what is the length of the diagonal to the nearest tenth of an inch? So that should have been a key word to tell me, or key phrase to tell me that we're probably going to have to select answer choice B or C. And go ahead and multiply 19.2 times 19.2 to see if you get close to 369. And if you don't, then multiply 16.4 times 16.4 and see what you get. Moving on to problem 3. A square tabletop has an area of 9 square feet. Let's start by drawing our square tabletop. And I like to write the area inside the picture. So the area is 9 square feet. What is the length of the diagonal of the tabletop to the nearest tenth of a foot? So I can look at my answer choices and probably safely eliminate D. I'm not going to cross it out yet, though. So we're looking for the diagonal, which is going to be this measurement here. And by now you should know that the diagonal of a square or rectangle is always going to be your C measurement, C, which is the hypotenuse. So how do we take the area of the square and find length A and length B? Well, let's think about the formula for area of a square. Area of a square equals length times width, or you can say base times height, or you can say side squared. And if I use side squared, that reminds me that the sides of a square are all congruent. So what number times itself will give me 9? And that answer is 3. So A has to equal 3, and B has to equal 3. So now that we have our A and B measurement, let's write our Pythagorean theorem and substitute our measurements. 3 squared plus 3 squared should equal C squared. So 9 plus 9 should equal C squared. So we need to find the square root of 18. Well, I know the square root of 16 is 4, because 4 times 4 is 16. So the square root of 18 has to be a little larger than 4, which brings me to answer choice A. Number 4. A set of steps is 12 feet long. Okay, great. The picture's already drawn for us, so we don't need to do that step. And 5 feet high. The steps are being replaced by a handicap ramp as indicated by the bold line in the diagram below. So here's your ramp. It's the bold-faced line. What will be the length of the ramp to the nearest foot? So we always want to identify our sides. So let's draw in our right angle. We know the side opposite the right angle is always going to be C. And we'll call 12 feet B, and 5 feet will be A. Okay? It doesn't matter if you reverse those letters. Let's write our Pythagorean theorem as we always do. A squared is 5 squared plus B squared. B is 12, so 12 squared will give us C squared. 5 times 5 is 25. 12 times 12 is 144. When you add those two numbers, you get 169. And 169, you should know by now, is one of your benchmark numbers. What number times itself will get us 169? And that would be answer choice B, 13 times 13. A shortcut to determining the answer is look at the last number in 13, the 3. 3 times 3 is 9, and that's our last number in 169. If you were to apply that rule to the other answer choices, 7 times 7 is 49. Well, that's a potential answer choice, but I know 15 times 15 is 225, so 17 times 17 is going to be much larger than 169. 1 times 1 is 1, and then I know 7 times 7 is 49, so you can safely eliminate those answer choices. So number 4, the correct answer is B. Let's move on to the back of the worksheet. We're starting over with number 1. The area of a square is 112 square inches. Which of these is closest to the length of the side of the square? So let's draw our picture of a square. We'll write in the information that's given to us, 112. And because it's a square, I know these two numbers, the sides need to be congruent. They need to be equal. So what I need to do is I need to take these answer choices and multiply them. So start with 10.3 times 10.3 and see if you get 112. Notice in the problem it says which of these is closest. So your number may not be exactly 112. We want to find the answer choice that's closest to 112. So multiply all these answer choices by themselves to see which one gets you closest to 112. Number 2. Which of the following expressions does not represent the area of the shaded square in the figure below? So let's think about this. Let's identify our A, B, and C in this Pythagorean theorem model. I know that the side opposite the right angle is going to be C. And I know that the area of these two squares, we'll say 12 squared is A and 5 squared is B. I note that the area of square A and the area of square B, when added together, will equal the area of square C. So A, we're looking for which of the expressions it does not represent. So A represents the Pythagorean theorem, right? You add up the two areas, you get the area of square C. When you add up the two areas, you get 169. So 169 is the area of square C. 13 squared also equals 169, so it can't be B. So we're down to one answer choice remaining, which is C. 17 squared does not equal the area of that shaded square. Number 3. Shown below is a right triangle with side lengths of 14.4 units, x units, and 15.6 units. Well, 15.6 will get plugged into this side length, which is C. And now we need to correctly plug these measurements into our Pythagorean theorem formula, a squared plus b squared equals c squared, to get our correct answer. I'll let you do that one on your own. It's fairly easy. Number 4. The last problem on this worksheet is a baseball diamond is a square where the distance between two consecutive bases is 90 feet. So let's draw our baseball diamond. Here's first base. Here's second base. Here's third base. And then we know home plate. This is home. And it tells us in the problem that the distance between any base is 90 feet. So all these are 90 feet. 90. And that's actually the true distance of a professional baseball diamond. From first base to second base is 90 feet. From second base to third base is 90 feet. From home plate to any one of the base, to first and third base is 90 feet. If the catcher throws a ball from home plate to second base, so the catcher's throwing the ball from home plate, I'm going to represent that with a dotted line. What is the approximate distance the ball will travel? Well, notice that I didn't really do a great job drawing the picture, but notice that here's my right angle. And notice that this shape is basically a square, and this dotted line from home plate to second base is the diagonal of the square. So you are solving for C. C is the unknown. So we're going to plug 90 squared plus 90 squared in for A and B and solve for C. Go ahead and answer problem 4 on your own.